Hello students, welcome to the classes. In this session, we will see few MCQs based on the chapter electricity. Right. Now first let's see few very important formulae in case of what? The chapter electricity. First formula, I equals to Q by T. What is I? Current. Okay. What about Q? Charge. What about T? Time. It's very important formula. And V equals to W by Q. V is potential difference. V is what? Potential difference. And what about W? Amount of work done. What about Q? Charge. Right. And V equals to IR. This is also called as Ohm's law. Right. Now V is potential difference. What about R? R is resistance. R is resistance. And what about I? I is current. Right. Now R equals to rho L by A. A is area of cross section. L is length. And what about rho? It is called as specific resistance. It is called as specific resistance. Now P equals to VI. P is power. What is V? Potential difference. We have used it already. What about I? Current. Or P equals to I square R. I is current, R is resistance, P is what? Power. We have used these symbols here already. What about P here? Again one more formula, V square by R. Right. Now the next two important formulae are what? R equals to R1 plus R2 plus R3 for series combination. That means, let's say there are three resistances here, okay, which are connected in series, R1, R2, R3. So R is given by what? R1 plus R2 plus R3 for series combination. Now for parallel combination, how they are connected? Like this. They are connected in parallel. Okay, if it is R1, if it is R2. Now 1 by R is given by 1 by R1 plus 1 by R2. Now here, these are nothing but equivalent resistances. They are nothing but what? Equivalent resistances. Right. Now these are the very important formulae which are used in case of what? Electricity. Now let's see the SI units now. Charge SI unit is coulomb, current SI unit is ampere, potential difference SI unit is volt, resistance SI unit is ohm, work done SI unit is what? Joule, and power SI unit is what? Watt. Right. Now these are the very important SI units. They may be asked for 1 mark like in MCQs. Right. Now let's see few important notes. See, ammeter is a device. Ammeter is a device used to measure current and is always connected in series. This is very important. This is always connected in series. Voltmeter is a device used to measure potential difference and is always connected in parallel. Right, this is important. And one more thing. When resistors are connected in series, the overall resistance increases. When resistors are connected in parallel, the overall resistance decreases. See, when they are connected in parallel, the resistance decreases. When they are connected in series, the resistance increases. Right. Now with this information, now let's solve few problems based on this chapter. Let's see few MCQs. Now let's see the first question. SI unit of electric current is. See, what is the SI unit of electric current? Just now we have seen the SI unit of electric current. What is that? Cool. SI unit of electric current is ampere. Right. So it is denoted by the symbol A. Right. So which option? Option B, ampere. We have just now seen SI unit of charge is coulomb, SI unit of Current is what? Ampere. So which option? Option B. Now let's see the second question. 1 kilowatt hour equals to. See, this is very important. Let's see. 1 kilowatt hour is equal to 1 kilo means what? 1000. So I'll write 1000. What is hour? Watt is a SI unit. So I'll keep watt as it is. Watt as it is. And what about hour? SI unit of time is what? Second, not hour. So you convert 1 hour to seconds. 1 hour means 60 minutes into 1 minute means 60 seconds. So 60 into 60, 3600 seconds. So here I will write 1 hour as 3600 seconds. Now here you see 36 as it is. Now here 1, 2, 3, 4, 5. I'll write 5 zeros here. Right. And watt into second is nothing but joule. Watt into second is nothing but joule. So which option? See here, option B, 36, and here you have 5 zeros. Right. 36, 5 zeros. So it means what? This is 36 lakhs joules. Right. So 1 kilowatt hour is what? 36 lakhs joules. Let's see the third question now. Okay. The opposition offered to the flow of current is known as, that is known as resistance. Resist means what? Resist means oppose. Resist means oppose. Opposition to the flow of current, opposition to the flow of current is called as resistance, and we also represent this using the symbol R. And what's the SI unit of resistance? Ohm. This is very important. Right. Now let's see the next one. Let's see the fourth question. According to Ohm's law, current through the conductor is directly proportional to. See, we have seen the formula for Ohm's law. V equals to IR. R is what? Resistance. So according to this, I is directly proportional to V. We can write I is directly proportional to V. What Ohm's law says? The current through the conductor is directly proportional to potential difference V across the ends of the conductor. It means which option now? It means option C, potential difference. Current through the conductor is directly proportional to the potential difference according to Ohm's law. Right. Now let's see the fifth question. If 4 joule of work is done in moving 2 coulomb of charge between the 2 points, then potential difference between them. We have seen this formula. V is equal to W by Q. V is potential difference, W is work done, Q is amount of charge. How much work done? 4 joule of work done. 4 divided by how much charge? 2 coulomb of charge. I'll write 2. Now 2 ones are, 2 twos are. How much you get? 2 volt. So what's the potential difference then? The potential difference is 2 volt. Do you have option 2 volt? No. That means which option? Option D, none of these. Right. Now let's see the next question now. A wire of resistance 4 ohm. A wire of resistance 4 ohm is cut into 2 equal parts. Then the wires are joined in parallel. Then the effective resistance is. See, 4 ohm is cut into 2 equal parts. Let's say this is my resistance. It is cut into 2 equal parts. So then each part will have how much? Each part will have 2 ohm of resistance because it is cut into 2 equal parts. So each resistance will be 2 ohm. And these 2 ohms are connected in parallel. They are connected in parallel here. Okay, 2 ohm and 2 ohm. Now what they have asked? They have asked what is the resistance? What is the equivalent resistance or effective resistance? See, I told you one thing. Either you can calculate here or you can just check the option. See what I told, if the resistance are connected in parallel, if resistances are connected in parallel, then what is the overall resistance? The resistance decreases, right? overall resistance decreases, right? So in that case, now see here you have what is the lowest resistance you have? Both are 2, right? So option has to be the value which is less than 2 because resistance has to decrease. Obviously, which option? Option B, 1 ohm. Or you can check also, for example, you may be having none of these also. In that case, we can check. So, what is the formula for parallel combination? 1 by R equals to 1 by R1 plus 1 by R2. Now see, 1 by R equals to 1 by R1 is 2 plus 1 by R2 is also 2. 1 by 2 plus 1 by 2. That is nothing but what? 2 by 2. How much? You get 1. So 1 by R equals to, you got 1. Now R into 1, R. R equals to, you get 1 ohm. So which option? Option B, 1 ohm. Right. Let's see the next question now. If 2 ampere of current flows through the conductor when potential difference of 10 volt is applied, they are given current, they are given potential difference, then they have asked resistance. We know V equals to I into R, according to which law? Ohm's law. Right. Now they have asked resistance. So what is R now? V divided by I we can write. How much V they have given? 10 volt. How much I? 2 ampere. Now 2 ones are, 2 5s are. You get what? 5. What is the SI unit of resistance? Ohm. SI unit of resistance is what? Ohm. So, or you can say volt by ampere is nothing but ohm. So, how much answer? What's the answer? 5 ohm. So, which option? Option C, 5 ohm. Right. Let's see the next one. Home appliances are connected in which combination? So, at your home, you will be having what? Electric bulbs, fridge, TV, and many other what? Electronic equipments, right? And they are connected in which combination? Series or parallel or any of the above or none of these? See, the home appliances are always connected in parallel combination. Why? Now let's see why. See, if I connect, let's say this is my fridge. Okay, now let's say this is my TV. If both of them are connected in series, now let's say if I have my switch here and let's say this is my voltage or AC voltage here. This is my AC voltage. See, I have one switch here. If the switch is closed, the current flows, and you can see the current flows through both fridge as well as TV. That means both are switched on at the same time. By just by just pressing one switch, both fridge and TV got switched on. Do you want it? You want separate switches for what? Fridge and TV. Because if you press one switch, if all of them, all of them are switched on, obviously we will be wasting the power, right? So if I connect in parallel combination, see, if this is my fridge and if this is my TV, okay. Now if I have switch for this here and if I have switch for this here, okay. Now if I connect it to some, let's say, AC voltage. Now if you want TV to be on, you switch it, you close the switch. If you want fridge to be on, you close the switch. Okay, so which equipment you want, you can close that switch, right? So that is why always the home appliances are connected in what? Parallel combination, not in the series combination, right? Now let's see the next question now. Two conductors of the same material have their diameters in the ratio 1:2 and their lengths in the ratio 2:1. See, diameters means d1 by d2. I will take. It's in the ratio 1:2. Diameter is nothing but 2 times resistance. So I will take 2 times R1 divided by 2 times R2. D1 I am taking 2 times R1, D2 I am taking 2 times R2. Because diameter is double of radius. This is 1 by 2. 2 cancel. We get R1 by R2 as what? 1 by 2. And they have also given their lengths are in the ratio 2:1. I'll take L1 by L2 is what? 2 by 1. Now they have asked their resistances. What is resistance formula given by rho L by A? They are made up of same material. This rho value, it is called as specific resistance. It depends on what? It depends on which material. So as you are using same material for both the conductors, so this resistance just depends on length and area. See how I will write the ratio as R1 by R2. I will write it as here. It doesn't depend on rho now because they are made up of same material. But it depends on what? The length. So I'll write it as what? L1 by L2 into A2 by A1. See why? L is in numerator. That means directly proportional. So if you have R1 here, you should write L1 here. But A is in denominator, inversely proportional. So if you have R1 here, in the denominator I will write A1. R2 is in denominator, so I write A2 in the numerator. That's how we can write. Now if they have asked what the resistances are in the ratio, R1 by R2 is equal to L1 by L2 is what? 2 is to 1 into what is area of cross section? Let's consider a conductor. Okay, if you take the cross section, so what figure you will get here? You will get a circle here. So what's the area of circle? Pi r square. So here I will write here pi r2 square divided by pi r1 square. Pi and pi cancel. So this is 2 by 1 into this square I will take common and write what? R2 by R1 whole square. Now this is 2 by 1 as it is. Here you have R2 by R1. But here you have what? R1 by R2. So if you reverse the ratio, 1 is to 2 will become what? 2 is to 1 raised to what? Square. Now what you get? 2 and 2 square is what? 4. 4 2s are 8. So which option? 8 by 1. The ratios are in what ratio? I mean the resistances are in what ratio? 8 is to 1. So which option? None of these. Why? Because here you have 1 is to 8, but that's not your option. You should get what? 8 is to 1. In the same order you should get. So which option? Option D, none of these, because the resistance ratio has to be what? 8 is to 1. Right. Let's see the next one now. The device used to measure the electric potential differences. We have seen already in the synopsis part. So what's the device? Voltmeter. See, there's a difference here. Voltmeter and voltmeter. So which option? Option B, voltmeter, which is used to measure what? The potential differences. Right. Let's see the next one now. The 11th one. The current of 2 ampere flows through the device when 220 volt potential difference is applied. The power consumed by the device is. What is the formula for power? Power is what? V into I. What is V? 220 volt. What is I? 2 ampere. 220 into 2, 440. What is the SI unit of power? Watt. So which option? Option C, 440 watt. Right. Let's see the next one now. 1 coulomb of charge is carried by how many electrons approximately? Yeah. So this one electron carries how much charge? It carries 1.6 into 10 raised to minus 19 coulomb. Now, how many electrons will make 1 coulomb of charge? If you want, you just take, cross multiply here. Let's take it as n here. Okay, n number of electrons. 1 electron, I'll just take it as 1 here. 1 electron makes, 1 electron has this much charge. How many electrons have 1 coulomb of charge? If you cross multiply, 1 into 1, 1 equals to n into this. N into 1.6 into 10 raised to minus 19. Okay, so now if you want the value of n, you take these terms towards LHS and divide here, you get what? 1 divided by 1.6 into 10 raised to minus 19. If you want n, you take them here and divide. 1 divided by 1.6 into 10 raised to minus 19. Now, 1 by 1.6, if you divide, you get 0.625. 10 raised to minus 19, if you take it above, it becomes 10 raised to plus 19. Now, n is equal to, if I shift this point here, you get 6.25 into 10 raised to this 19 will become 18. Because you are shifting 1 point towards right side, you should decrease the power. So 6.25 10 raised to 18. It is nearer to what? 6 into 10 raised to 18. Which option? Option C. 6 into 10 raised to 18. Right. Let's see the next one now. The magnitude of charge of electron. Just now I told. What is the charge of electron? E is given by what? 1.6 into 10 raised to minus 19 coulomb. So which option? Option D. See, look at the difference between option C and D. C is 10 raised to plus 19, but D is 10 raised to minus 19. Electron charge is what? 10 raised to minus 19. So which option? Option D. Now let's see the next one. Okay, the ratio of potential difference to the current. See, potential difference means what? V. Current means what? I. What this ratio they are telling? According to Ohm's law, V is equal to what? I into R. If you take R is equal to, if you take V here, I here, it divides, so you get what? R is equal to V by I. So the ratio of potential difference to current is what? Resistance. So which option? Option C, resistance. Right. Let's see the 15th question now. The resistance of conductors is. See, there are basically three types of materials. Conductors, insulators, as well as semiconductors. As well as what? Semiconductors. Now here, conductors have low resistance. They have low resistance. Okay, insulators have what? High resistance. Resistance means what? Opposition. Right. So they don't oppose much conductors. That is why they allow the electricity to flow through them. But insulators oppose very much. Right. That means they have high resistance. That's why current will not flow through insulators easily. But semiconductors, their conductivity or resistivity is between what? Conductors and insulators. So in that case, resistance of conductors is what? Low. So which option? Option A, low. Now let's see the next question. Alloys are used the most in the electric heating devices because what are alloys? The mixture of two or more metals or non-metals. Okay. For example, steel. Steel is made up of iron and carbon. Okay. And alnico. If you take alnico, it is made up of what? Iron, aluminium, nickel, okay, and cobalt. So mixture of metals or non-metals is called as what? Homogeneous mixture is called as what? Alloy. And why we use alloys generally in the electric heating devices? There are two reasons. One is the resistance of these alloys is more compared to the metals. So that's the first reason. That is first is correct. And second one, they generally do not get what? Rusted, in the sense, for example, if you take iron, it gets rusted very easily compared to steel. Steel generally doesn't get rusted, right? So that is why, so the rusting is nothing but what? Process of oxidation, right? So they generally do not oxidize readily at high temperature. Both are correct. So which option you should select? Option C, both A and B, because both A and B are correct. Right. Let's see the next one now. The metal generally used in transmission lines is. So which metal you will use generally in the transmission lines, or the lines, the wires you use in case of what? Home appliances. Which metals you will use? You will use copper wires, right? So option B, copper. Now let's see the next one. The resistance of conductor depends on. See, resistance depends on the length of the conductor. It is directly proportional to length of the conductor, and resistance is inversely proportional to area. It depends on area also, it depends on length also, and resistance, it depends on temperature also. So resistance depends on temperature, length of conductor, cross-sectional area. Also resistance depends on nature of material. Okay. So it depends on all these four factors. So here they are given three factors, and fourth option is what? All the above. So which has to be correct? Option D, all the above. Right. Let's see the 19th question. When three or more resistors are connected in series, the overall resistance is. I told you this in the synopsis. When the resistors are connected in series, the overall resistance increases. So if it increases, in that case, which option? Option A, you can see the overall resistance is more than individual resistances. Let's see why. Let's say I am connecting 2 ohm, 3 ohm, 4 ohm. Okay. Now, if I connect them in what series, what about the resistance, overall resistance? 2 plus 3, 5, 5 plus 4, 9. 9 ohm. This 9 ohm is more than all of them here, right? So that means this overall resistance is more than the individual resistances. Which option? Option A. Let's see the 20th question now. Two resistors of resistances 3 ohm and 4 ohm are connected in series. The overall resistance is. If the resistors are connected in series, R is given by what? R1 plus R2. Right. So 3 ohm plus 4 ohm. 3 plus 4. How much? 7 ohm. The effective resistance or overall resistance is what? 7 ohm. So which option? Option D, 7 ohm. Let's see the 21st question. The filament used in electric bulbs is made of. So what's the option? Generally the bulbs use which filament to light? Okay. Option D, tungsten. Right. Tungsten is the filament which you use generally in the bulbs. Right. Let's see the 22nd question. Yes. Which of the following are generally good conductors of electricity? See, metals are good conductors of electricity generally. Why? Because they have free electrons. Metals contain free electrons. That is why they are good conductors of electricity. So these free electrons are responsible for what? The conduction of electricity. So which option? Option A, metals. Let's see the 23rd question. 1 joule per coulomb is equivalent to. See, joule is a unit of energy. This is a unit of energy or work. And coulomb is a unit of what? Charge. Now here you see joule, work done. I will write per coulomb we have. So divided by, I will write coulomb is charge. What is W by Q? W by Q is nothing but V. Potential difference is nothing but what? Amount of work done divided by charge. So V is what? Potential difference. What is its SI? What is its SI unit? Its SI unit is what? Volt. So 1 joule per coulomb is same as option B, 1 volt. Right. Let's see the 24th question now. Okay, the device used for measuring the current. See, the device used to measure current is what? Ammeter. So here you have two options containing ammeter here, option C and option D. But how the ammeter is connected? We have seen in the synopsis, it is connected in series, not in parallel. So which option? Option C, ammeter and series. Now let's see the 25th question. 1 milliampere is equal to. See, milli means 10 raised to minus 3. Micro means 10 raised to minus 6. Nano means 10 raised to minus 9. So remember these prefixes, right? So nano means 10 raised to minus 9, milli means 10 raised to minus 3, and micro means 10 raised to minus 6. So here they have asked 1 milliampere. Milli means 10 raised to minus 3. So 1 milliampere means 10 raised to minus 3 ampere. So which option? Option D, 10 raised to minus 3. Okay.